let's take a look at some rational functions. A rational function is a function that is the ratio of two polynomials. The domain for a rational function is all real numbers except when the denominator could equal 0. When that happens, we often see something pretty dramatic called a vertical asymptote. So in this first example, we see x equals 2 is outside of the domain of the function, and we see a dramatic kind of thing happening here. The graph climbs up along the vertical line on the left side and drops down along the vertical line x equals 2 on the right side. Likewise here, x squared minus 4 equals 0 at 2 and negative 2, and we see that similar feature. And here, the 1 over x part, this is a little bit more complicated. If you think about this function, it's not in a strictly a ratio of two polynomials, but we can think of it as a rational function because we could rewrite it using a common denominator. X is the same as x squared over x, and so we could write this function as x squared plus 1 over x. So that would give us an expression in the traditional form of a rational function. And of course, this last example has a vertical asymptote at 0. A second interesting feature of rational functions is that they can have horizontal asymptotes. Whether they do or don't depends largely on the degree of the numerator and the denominator. If the degree of the top and the bottom is the same, then a horizontal asymptote will exist, and the value will be the ratio of the two lead coefficients. So in this case, the lead coefficients are both 1, so we get a horizontal asymptote at y equals 1. In the second example, the bottom has a higher degree compared to the top. In this case, the horizontal asymptote will always be at 0. And finally, in the last example, if we look at this converted form, we see the degree of the numerator is larger, and in this case there is no horizontal asymptote. Now let's look at a quick example where we can identify horizontal and vertical asymptotes from the graph of a function. In this example here, we see vertical asymptotes at x equals 2 and x equals negative 2, and we see a horizontal asymptote at y equals 0. There's another feature that affects the domain of the graph. Notice there's a little open dot here, so there's actually a hole in the graph. So if we wanted to describe the domain of this graph, we would have to leave out 2, negative 2, and also 4. In the second example, there are no vertical asymptotes, and there are also no holes in the graph, so the domain would be all real numbers. And we do happen to also have the formula here, so we can see that this denominator never equals 0. There's no x value that will give us 0 if we plug it into 2x squared plus 7. We can also see from the formula that the degree is the same. The top and the bottom are both degree 2, which means there will be a horizontal asymptote, and it will be at the ratio of those two numbers. So we could say 1.5 or the fraction 3 over 2. I'll dig into some additional examples in another video. I hope you enjoyed this one. Thanks for watching.